Hello students, in this video I am going to discuss about the basic concept of gravitation. The force of attraction between any two bodies of the universe is called gravitational force or gravitation. Our knowledge about gravitation didn't develop only as a result of Newton observing a falling apple. Some thinkers and scientists before Newton already had some idea about gravitational force. Indian scholars had been using the term Gurutva, Akarshan, meaning attraction by a massive body. From a time much before Newton, the study of motion of the planets also helped in understanding the nature of this force. More than 1,000 years before Newton, Aryabhat wrote a book called Aryabhatiya, in which he described the motions of the moon and the planets. From Kepler's work, it is possible to show that gravitational force is proportional to 1 by r square. Now, force of gravity. The gravitational force between a body and the earth is called force of gravity. So, a body falls freely towards the earth due to force of gravity. So, the gravitational force between a body and the earth is called force of gravity. A body falls freely towards the earth due to force of gravity of the earth. Now Kepler's law. The Danish astronomer Tycho Brahe spent more than 20 years measuring the positions of the sun and the planets at different times. Brahe He took Johannes Kepler as his student during the final years of his work. Kepler had a wonderful ability in mathematical computations. Kepler analyzed the data collected by Brahe and put forward three laws of planetary motion. First, all planets move in elliptical orbits with at its one of the foci. So, first law that is known as the law of orbit. So, according to Kepler's first law, all planets move in an elliptical orbit with the sun at its one of the foci. With the sun at its one of the foci. Second, the line joining a planet to the sun sweeps equal areas in equal intervals of times. So suppose that first two positions of the planets A and B and next two position that is C and D. If planets take same time to move from A to B and from C to D, then the area swept by the planets that is equal to ABS is equal to area CDS and both are equal. So a second law of Kepler that is also known as a law of area. So the line joining a planet to the sun sweeps out equal areas in equal interval of the time. Third, the square of the period of revolution of a planet around the sun is directly proportional to the cube of the average distance of the planet from the sun. So, third law that is also known as the law of periods. So, according to Kepler's third law, the square of the period of revolutions of a planet around the sun is directly proportional to the cube of the average distance of the planet from the sun. Therefore T square directly proportional to R cube. Now I am going to discuss about universal law of gravitation. And according to universal law of gravitation, it is also known as Newton's law of gravitation. So this law, according to this law, the magnitude and directions of the gravitational force between two bodies are given by the universal law of the gravitation, which was formulated by the Newtons. This law states that the force of attraction between any two bodies of the universe is directly proportional to the product of their masses and inversely proportional to the square of distance between them, and it acts along the line joining their centers. Here we have assumed two bodies of masses m1 and m2 separated by distance r, and they apply equal and opposite force on each other. So let two spherical bodies of masses m1 and m2 are separated by distance r. Then by universal law of gravitation, F is directly proportional to the product of the masses. That is called F is directly proportional to m1 into m2, and F is inversely proportional to r square. And combining first two, we can write F directly proportional to m1 m2 and inversely proportional to r square. Or it can also be expressed that F is equal to z m1 m2 by r square, capital Z here. So here capital Z is constant known as universal gravitational constant. The value of Z was experimentally measured in laboratory by Cavendish, Henry Cavendish. This value is 6.673 into 10 to the power minus 11 Newton meter square per kg square. So the value of capital Z, the universal gravitational constant, remains same at all places. It will not change. Unit of Z, we can write capital Z is equal to F into R square divided by M1 into M2. We know that SI unit of force is Newton, distance is meter. So that here is a meter square. Mass is kg. So kg into kg, that will be the kg square. So SI unit of capital Z is Newton meter square per kg square. Now definitions of Z. We know that Z is equal to F into R square by M1 into M2. If M1 is equal to M2 is equal to 1 kg, R is equal to 1 meter, then universal gravitational constant is equal to the force of attraction between two bodies of unit masses separated by unit distance. Universal gravitational constant is equal to the force of attraction between two bodies of unit masses separated by unit distance. So this is the definitions of the universal gravitational constant. Now one numericals. Find the gravitational force between two protons kept at separations of 1 femtometer. We know that 1 femtometer is equal to 10 to the power minus 15 meter, and mass of proton is 1.67 into 10 to the power minus 27 kg. And we know that F is equal to Z m1 m2 by r square. Here we will put the value of capital Z, that is 6.67 into 10 to the power minus 11. Value of M1 1.6 into 10 to the power minus 27 into M2 is also 1.67 10 to the power 27 divided by R is given 10 to the power minus 15. That here is a square. So 10 to the power minus 15 into 10 to the power minus 15. So first multiply here, it will be equal to 6.67 into 1.67, or first of all add powers, a power of 10. So here it will be equal to 10 to the power minus 65 plus 10 to the power 30, and it will be equal to 10 to the power minus 25. Now here 6.67 uh, 6.67 into 6. It will be the 6.67 square here. So 6.67 into 6.67 square into 10 to the power minus 25. Now 6.67 into 2.75, that will be equal to into 10 to the power minus 35, or it will be equal to 18.5 426 into 10 to the minus 25, or we will write here 8.85 into 10 to the power minus 34 Newton. So by putting the value and we will calculate like this, it will be the answer. Now next question is that two bodies A and B of masses m and 2m respectively are kept at distance d apart. Where should third body be placed between them so that the net gravitational force on it due to the two bodies will be zero? So suppose that body is placed at point O, suppose its mass is m dash. Now the body at point A and B, the apply force on mass m dash that is placed at O, and the net force on the body placed at O, that will be the zero. It means that the force between m and m dash will be equal and opposite to the force between m dash and 2m. So here we will write, suppose that AO is equal to x and AB will be equal to the d minus x, because distance between two bodies is given d meter. So if AO is equal to x, then OB is equal to d minus x. Now force on m dash due to mass m, F1 is equal to gm m dash by x square towards A, and force on m dash due to mass 2m, F1 is equal to gmm into 2m dash by x square, that is towards B. The net force is 0, therefore F1 is equal to F2. Now gm m dash by x square, g into 2m into m dash by d minus x square, g to g will be cancelled, 1m to 1m will 1m to 1m will be cancelled. So here net force is 0, therefore F1 is equal to F2, and Gm m dash by x square is equal to G into 2m into m dash to m dash cancel, m to m cancel, G to G will be cancelled. Now cross multiply here, d minus x whole square is equal to 2x square, and it will be equal to d minus x is equal to plus minus root 2x, or now we will write here x plus minus root 2x, take x common, 1 plus minus root 2, therefore x is equal to d by plus 1 d by 1 plus minus root 2, or x is equal to d by 1 plus root 2 or d by 1 minus root 2. As x cannot be negative, so x is equal to d by 1 plus root 2. So if body is placed at this distance, then the net force acting on it will be 0. Now next question. Three balls A, B and C are kept in a straight line. The separations between A and C is 1 meter, and B is placed at the midpoint between them. The masses of A, B, and C are 100 gram, 200 gram, and 300 gram respectively. Find the net gravitational force on A, B, and C. Net gravitational force on A, B, and C. Here M1 is equal to 100 gram, therefore it is equal to zero point 0.1 kg. M2 200 gram equal to zero point 0.2 kg. M3 300 gram 0.3 kg. Now force on A due to body B and C. So here FA is equal to FAC plus FAB. Means force on A will be equal to force between A and C plus force between A and B. Here G into zero point 0.1 into zero point 0.3 by 1 square, because distance between A and C is 1, plus G into zero point 0.1 into zero point 0.2 divided by zero point 0.5 square. Now take z common here, it will be equal to 0.03 by 1 and 0.02 by zero point 0.5. Now value of z is 6.67 10 to minus 11, and we can write here 3 by 100 plus 2 by 25, take LCM 100, it will be 3 plus 8, and 6.67 10 to minus 11 into 11 by 100, 73.37 into 10 to the power minus 13, 7.337 into 10 to the power minus 12 Newton. This is equal to 7.34 into 10 to the power minus 12 Newton, that is towards C. Now force on B, that is equal to FB minus FAB. So force on B is equal to force between BC minus force between AB. So here we will write G into zero point 0.2 into zero point 0.3 divided by zero point 0.5 square minus G into zero point 0.1 into zero point 0.2 zero point 0.5 square. Now G is equal to 0.06 by 0.25 minus 0.02 by 0.25. Here 6.67 10 to minus 11, 6 by 25 minus 2 by 25. Here 4 by 25. Now we will write here 26.68 by 25. It will be equal to 1.066 into 10 to minus 11 Newton. This is equal to 1.07 into 10 to power minus 11 Newton towards C. Now force on C will be equal to force between AC plus force between BC. This is equal to G into zero point 0.1 into zero point 0.3 by 1 square plus G into zero point 0.2 into zero point 0.3 0.5 square. Or this is equal to Z 0.03 by 1 plus 0.06 by 25. It implies G into 3 by 25, 3 by 100 plus 6 by 25. Take LCM and solve it. It will be equal to 6.67 10 to power minus 11 into 27 by 100, or this is equal to 1800 18009 into 10 to the minus 13, or this is equal to 1.80 into 10 to the minus 11 Newton, that is towards C. So in this way we can solve the numericals based on the universal law of gravitation. So in next video we will discuss about the free fall, uh, acceleration due to gravity, and mass and weight, etc. Thank you.